right, so Unit 5 was all your formulas for like area, volume, all of that stuff. So area for these, we're going to have area of a rectangle is length times width. And if we want to draw a picture here as length times width. Area of a triangle is 1/2 base times height. So like if you have a triangle, it is also important to know your base and your height have to be perpendicular. Right there. So the height is only going to be a side of a triangle if you have a right triangle. Like if it looks like this, you could call this base and this height. But a lot of times it has to be that line that goes like down through the middle. Okay. Area of a trapezoid is one I'm afraid that you might see. I know the release test had an area of a trapezoid problem on there. And I also, I say afraid because I think you'll see rectangles and triangles as well, but I think a lot of you know those. Trapezoid we're probably less familiar with. So your area for a trapezoid is 1/2 height base 1 plus base 2. And trapezoids look like this. This would be your height. This would be base 1. This would be base 2. Okay. I realized whenever I was going over this with second period that I forgot something really important here. So area of a circle and area and a circumference I put on here. I forgot to put arc length and sector area on here. So I'm going to add this over here in that blank space. But first, area of a circle is pi r squared. Circumference of a circle is 2 pi times the radius. Those are easy to get mixed up, so those I would look at. You may or may not see the circles, those two, but what you are almost definitely going to see is arc length and sector area. So we're going to add that in. You got a little bit of extra room right there. Alright, so arc length is just a fraction of your circumference, because when you're looking at arc length, you're looking at just the edge here of that circle, right? That little piece of the edge. So it's just a piece of the circumference. So if you're in degrees, your arc length is going to be your angle over 360 times the circumference, which is 2 pi times the radius. Now, for radians, we had an easier formula. Do you guys remember that other formula we used for radians? Nope. You're close. So the one that we actually used was just the angle times the radius. But you guys had this nice formula sheet that told you what the formula was, right? So you're not going to have that on Monday. So if you know the degree formula, 360 degrees is the whole circle, right? If we change it to radians, the only thing that changes is what the whole circle is. What is the whole circle in radians? 2 pi. So it's the same formula, but just in radians. Now, there was a shortcut that we used on this. It was the angle times the radius. The reason is because the 2 pi right here in the bottom of that fraction cancels with the 2 pi here. But if we don't have that memorized, it's not very helpful to us because we can't use something that we don't even know. So if you memorize the degree formula, which you have to know the whole thing, nothing cancels with the degree formula. If you know the degree formula, you can do the same thing with radians. It's just instead of 360, you use 2 pi. And it's going to happen, even if you start from this, the 2 pi's cancel, and then you can do the problem more easily. Okay? We also need to know sector area. When we're talking about sector area, that is the area of the whole slice of pizza, not just the crust, but the whole slice for that. And so this is a fraction of the area of the circle. So my area in degrees is going to be angle over 360 times the area, pi r squared. Or if I'm doing radians, it's going to be my angle over 2 pi times pi r squared. There was a shortcut version of this. It is area equals 1/2 angle times the radius squared. However, that, you would have to have memorized. We don't have any of these memorized. Arc length and sector are specific standards that are in our curriculum. I think you're going to see one or both of them on the exam. So those would be ones I would make double sure I have memorized that I can use. Okay, everybody good there? All right. We got volume formulas. Volume of a prism. I've got several prisms drawn over here. Volume equals area of the base times the height. That capital B is the area of the base. Okay. So, like for example, if I'm looking at the triangular prism, right, what shape is my area of the base going to be? Triangle. So I would do my volume would be the area of the base is 1/2 base times height. And I'd have to multiply that by the height of the prism. So like this right here would be the height of the triangle. I'm going to call that H1. I'm going to call this one H2. This right here would be the base. And then this side right here would be H2. So depending on the shape of your base, you have to put that there where the capital B is. There we go. Okay. So if I had, like, for example, the rectangular prism, I've got a rectangle for my base. So I'd volume equals the area of the base is length times width. And then I'd multiply that by the height. So I'd have length times width times height. You guys probably already know that one because it's really common, but that's the same idea, right? I hope they do not give you pentagonal, hexagonal, octagonal. I hope they might give you a picture of one and ask you what it is. I hope that they do not give you one and ask you for the volume. I think it's probably going to be triangles, squares, rectangles, or maybe a trapezoid. But I there was nowhere in the examples that they had something like this, but it also didn't exclude it either. And figuring out how to do it is really hard, so we didn't have time to do that here. All right, so volume of a cylinder is really the same as a prism, because what is the shape for your base for a cylinder? Circle. And what is the area of a circle? Pi r squared. So pi r squared is the area of your base multiplied by height. Pyramids and cones are almost the same as prisms and cylinders. But what fraction do we have that has to go in front of them? Not a half. 1/3, right? So I don't think I actually got to do this for you guys because we were out, but I think I put a video in the notes where you had to watch videos. Like if I go fill up a cone and try to pour it into a cylinder that has the same height and the same radius, I've got to fill that up and pour it in there 3 times, right? So like if you, you know, like at water coolers, a lot of times they'll have those like cone cups. They only hold like 1/3 of what a cup that same size would hold. So volume is 1/3 area of the base times height. And for a cone, volume is 1/3 pi r squared times height. Okay, and then we need volume of a sphere. That one is 4/3 pi r cubed. Okay, so centers of triangles here are the next thing that we've got. The circumcenter is the intersection of the perpendicular bisectors. So perpendicular bisectors are these lines here that cut the side in half and are perpendicular. Okay, in a triangle where you have a circumcenter, these 3 lines right here are congruent. So the lines from the center to the vertices are congruent. The next one is called the incenter. It is the intersection of the angle bisectors of a triangle. And it is, in it, all 3 of these little pieces are congruent to each other. On these problems, it's not good to assume because those pictures may not be drawn to scale, but they are usually drawn to scale. So if you must, just look at them and see if you think they look like they're the same. If you can't remember for sure. The last one that I have on here is a centroid. Centroid. Okay. It is the intersection of the medians. A median goes from the vertex to the opposite side and cuts that side in half. Okay. The special property of the medians here is that if I know this little piece right here equals 5, what would be the length of BP here? 10. Okay, so the medians are going to be cut in a way that the short piece is half of the long piece. There is also an orthocenter. I purposefully left that off of here because it does not have any mathematical significance. Like there's not any problems where it's going to give you this and ask you to do a problem with it. And I figured we already had so many things to remember that I was just going to leave that one off. I don't think they're going to ask you anything about that one. Could be wrong, but you never know. Okay, questions so far? All right, we're moving along nicely. All right, properties of parallelograms. So for a parallelogram, remember those look like this. Let's draw us one over here. When you name a parallelogram, let's say that this parallelogram is named A, B, C, D. When you label a parallelogram, because it matters on one of those release test problems, you have to label it by going around the edges. It does not matter where you start. It does not matter which direction you go, but you have to go around the edges. So, for example, if I decide to put A right here, then B could go here or here, but where can it not go? This corner right over here. I cannot cut across the parallelogram. So, if like I put A here, I could put B here, C here, D here. I didn't have to start that way. I could put the A somewhere else. I could put the A right here. We call this A, B, C, D. But you got to go around the edge whenever you name it. Okay? So, opposite sides in a parallelogram are congruent. So, they're the same length. And they are parallel. Okay, so these sides right here are equal to each other. These sides right here are equal to each other. They're also parallel, so they'll mark that with one arrow on both of these to show those two are parallel. Then they might do two double arrows. Like that. Opposite angles, so like we're talking A and C here, or B and D. Opposite angles are congruent. Consecutive angles add up to, anybody remember that? 180. Okay? Give me an example of consecutive angles here. What could be two angles that would be consecutive? A and what? Well, we don't know for sure what the angles are here. So A and so A could be consecutive with which two? B. A and B are consecutive. They're on the same side. Or A and D could be consecutive right there. So they're on the same side. Basically, we like split the parallelogram in half, either vertical or horizontal. They'd be on that same side. Okay, it's just not the one the opposite corners. Those are the opposite angles. And the last thing here is that diagonals bisect each other. Okay, so that means that it does not mean that diagonals are equal to each other, because AC is a lot longer than BD. it means that they cut each other in half. So like this little piece is congruent to this piece. I guess I need 3 for that, and this is congruent to this. Okay. Questions? All right, circles. I just copied and pasted the circle stuff from another review sheet. So what I would like to do here, there's nothing you really have to fill in. What I would like to do is go through and put some numbers on this, because I think sometimes students have a little bit of a hard time knowing exactly what it means with the variables there. So, like for example, for this one right here, let's say that this angle right here is 60 degrees. What's the measure of the arc there that goes with it? Nope. It is also 60. So for a central angle, they match. They're the same. Now, what about if this arc right here is 60 degrees? What would the angle that goes with it here for the inscribed angle be? Isaac? It'd be 30. It's going to be half of the arc. Sometimes I think students do better seeing like actual numbers in their examples than the formulas. Okay. If I have a diameter right here, what's the measure of this arc? 180. So if that arc is 180, what would the measure of this angle right here have to be? It's going to be 90, which it has marked. That's supposed to be a right angle right there. I kind of did a weird rectangle. Okay. I actually don't think I did this one, but it's a good one to know. If you have an inscribed quadrilateral, so if you have like a 4-sided figure that's on the inside of the triangle and just your vertices hit the triangle, opposite angles have to add up to 180. So in this case, A plus C would have to equal 180, and B plus D would have to equal 180 for that. For these down here, let's say that this arc right here is 100, and that this little arc right here is 20 degrees. And I'm looking for measure of angle 1 right here. Okay. So the rule for this one it shows us is x minus y divided by 2. So big minus small divided by 2. So we would go 100 minus 20 divided by 2. That would give us 80 over 2, which would be 40 degrees. So in this case, if those were my measures, I'd get 40. All right. For the next one, a lot of times on this, they may only give you like one piece. They might tell you that this arc right here is 100 degrees. Now, it's the same rule as the one we just did. You need to do the big arc minus the small arc divided by 2. But they only gave us the little one. How would we find the big arc on this one? $360 minus 100. So this part over here, that would be 260. And then to find angle 1 over here, we would have to do 260 minus 100 divided by 2. So that'd be 160 divided by 2, which would give us 80 degrees. I do not like the picture that they used for this because it looks like X and Y are equal to each other. They are not necessarily. They could be, but they're not necessarily. I probably would have drawn my picture more like this right here, where you can see the angle, the arcs are probably not equal to each other. So like if I knew this arc right here was 40, and I know this arc right here is 120. And I'm looking for one of these angles right here on the inside. Whenever you have something that crosses on the inside, oh, I just thought of another one that's not on here. Why didn't do that for a second period. So if they cross on the inside, it's basically just the average. We add together, divide by 2. So we're going to do 120 plus 40 divided by 2. That's going to give us 160 divided by 2. We'll also get 80 for this one. It's not related to the last problem. I just happened to pick something the same. I forgot to put a problem like this on there. Actually, I forgot several things like this. Alright, what if I have like A, B, C, D? Does anybody remember what you do with it when it's the pieces on the inside, not the angle? Almost. You're on the right track, but it's not plus. It's times. A times B equals C times D. There's a couple other things I forgot. There's so many things. This is so much stuff. Alright, this last one that's right here, let's say this arc right here, let's say that arc right there is 240 degrees. What would the measure of this angle right here be? Half of it, 120, right there. Okay, questions? All right. Equations of circles. Equations of circles really should, unless they really get crazy, they should be pretty easy problems for you, even if you don't know what I'm about to tell you right now. So if I have x minus h squared plus y minus k squared equals r squared, the center is going to be at hk. Okay? The r right there stands for the radius. So that means when I have the example that says what is the center and radius of x minus 3 squared plus y plus 2 squared equals 25. Rylan, what would the center of that be? Perfect. 3, negative 2. Right? Peyton, what about the radius? It comes from 25, but it's not 25. Because this number right here is the radius squared. It's going to be 5. We'll take the square root of it and we'll get 5. Now, I personally would not dream of ever picking up a calculator on this because I have taught circles for like 15 years now. Right, in some form or fashion. And I know this rule so well, I don't question myself at all. However, you guys learned this rule for like a day or two, right? And you might be feeling a little bit shaky. In fact, I think Rylan almost started typing, right, whenever I asked you that question. So, what I would encourage you to do on the exam, even if you do feel pretty good about this, you have a really long time to take this exam. So, what I would encourage you guys to do here is go to Desmos, take the time, type it in, x minus 3 squared plus y plus 2 squared equals 25. It is going to graph it for you. You can type in the center that you just picked, 3, -2. Make sure it's in the middle. If it's not, then you've messed up, right? You can even count the radius. 1, 2, 3, 4, 5. So definitely, the formula makes it quick to do. Like on the ACT, I would never tell you to do this. On the ACT, you need to answer that quick and move on. You got plenty of time on this test. If you can't do it in 4 hours, then you probably just can't do it, right? None of you have any disabilities that would make you take longer than that, I don't think. So, so there might be somebody out there that needs more than 4 hours, but I don't think any of you do. You got plenty of time. Type it into Desmos, double check it there. Because sometimes you might make a mistake. Like you might say that radius is 25, right? But whenever you graph this, you can tell the radius is definitely not 25 for that. So that'll help you. Okay? All right, any questions? All right, so we're almost there. We don't have much left. I'm not going to fill in the whole unit circle right now. I put it on there. It's definitely something good to fill in. You guys have the unit circle already. You can fill it in on your own time if you would like. But I'm going to fill in some of this other stuff. So 360 degrees equals how many radians? 2 pi. Okay, that's important to know. To convert radians to degrees, you're going to take your radians and multiply by 180 over pi. To convert degrees to radians, you're going to do pi over 180, multiply by pi over 180. Again, you don't have a formula sheet on this, so I always remember this because like radians might be something like pi over 2. And whenever you change this to degrees, you typically are going to see that pi on the bottom so that the pi's cancel. So that means 180 has to be on top, right? Pi's cancel, 180 over 2 equals 90 degrees. Okay? When you have degrees, you got like, you might have 120 degrees, right? If you have degrees on the top of this fraction, it's not a fraction really, but if you did, it'd be on the top. You need degrees on the bottom of the fraction so that those degrees cancel out technically. So that'd be 120 pi over 180. You would reduce that, which is going to give you 2 pi over 3. You can reduce it in your calculator or by hand. Let me show you one more thing that I just thought of that I probably should have shown second period. Let's say that you got a problem that says convert 120 degrees to radians. If it is 120 degrees, you can go to Desmos. You can get rid of this stuff that's already there. And you can change it here. And if I go to degrees, there's 120 degrees, right? If I'm trying to change that to radians, if I go over here and change it to radians, 2 pi over 3 is in the same spot. So that can maybe help you if you get one that easy. You might. I don't know if they'll put one that easy on there or not. Sorry, I think I'm involved in the group text here. I'm going to cut my sound off. So quit thinking. All right. Questions there? Positive angles go in which direction on the unit circle? Not clockwise, counterclockwise. And you may want to draw yourself like a little picture here. That means this direction. And then negative angles go in the clockwise direction. So that would be starting from here, this direction. Okay. Unit circle there is you can fill that out. Remember, let's go ahead and do this one real quick. That's cosine of x and sine of x. That's really important to know. And unit circle, you can fill that out later if you would like. That's not a terrible thing to look at also right before your exam. Okay, just a couple more things. Graphs of sine and cosine, so like our wavy graphs here. The amplitude is the absolute value of A, which is always positive. The period of a graph is 2 pi divided by b. And the midline is y equals c. Oh, yes, it can be. Or, if you're in degrees, it is 360 divided by b. Very good. Yeah. I think you're probably going to see it in radians more than likely, but there's a chance that they might do it in degrees. And if they do, just like in our sector formulas, that 2 pi can be 360 if it's in degrees. Good point. All right, so that means this number right here, whatever's in front of your sign, that is your amplitude. And this number back here, whatever you're adding or subtracting, that is your midline. So that's helpful to know. B is not your period. You got to do 2 pi over B to find the period. So I'm not going to show you that. And so to make sure we know what we're talking about, let's label these things on this graph that I have down here. The midline is the line that goes through the center of the graph. So on this graph I have here, I put it in there. It would be that purple line right there. That is your midline. In this particular case, the midline is y equals 2. Because it right there hits the y-axis of 2. The amplitude is the distance from the midline to a maximum point. Or you could say minimum point there because it should be the same distance. So from that midline up to that maximum, that length right there is your amplitude. For this problem, that would be 3. For this problem. Okay. A lot of students on this were missing these problems because they were maybe given like the highest value. Like they would say amplitude is 5 here because that's the highest that it goes. That is not your amplitude. It's from the distance from the midline to the highest. You also, some people would put 6 because that would be like lowest to highest. You want half of that. And then the period is, in my opinion, the hardest one to find. It is the distance that it takes for the graph to begin to repeat. So what I like to do for that is start at the y-intercept right here. Start at that y-intercept. Why is it not letting me switch? Okay. You are looking at that y-intercept. You're tracing your graph until it starts to repeat itself, which happens right here. That value right there is 2 pi. So the period of this graph would be 2 pi. Okay, questions on that? All right, just our little bit of statistics left, and we are done. I think they're going to give you these equations for margin of error because on the questions that they have released that I have seen, they have given the margin of error there. So, the formula for that is 2 times s over the square root of n. S is standard deviation.